All right, we're going to talk about geometric sequences. First of all, what is a geometric sequence? This is a sequence of numbers in which the ratio remains constant, and it is found by dividing each term by its previous term. Now, I'm going to make that simple for you. When you're talking about geometric sequence, we are going to be looking at what we are multiplying in order to find the next term. Okay, so let me give you just a simple example of geometric sequence. So let's say we start with 1, we go to 2, go to 4, 8, 16, and my sequence could continue on. So this is a geometric sequence because each previous term is multiplied by 2 to find the next term. Okay, so if I started with 1 and I multiplied by 2, I got 2. Then if I multiply 2 by 2, I get 4. Then if I multiply 4 by 2, I get 8. And you see how the pattern continues on. So this is a geometric sequence. So we want to look for the equation of a geometric sequence. Now, this is the form of the equation that you'll need to write down in your notes. Okay? And I want to explain what each of these terms represent. Okay? So the a sub 1 is the first term in the series. The r represents the rate. Okay? Now, that is what are you multiplying by? Okay? Now, the a sub n and the n minus 1, stays in the formula. Okay? So we're going to look at a couple of things down here, a couple of examples. And we're going to see if we can write the equation based on this form of the equation for this series. Okay, so first of all, they want us to determine, is it a geometric sequence? That means, did you multiply something by something to get each term? So if I say 4 times 3, I'll get 12. So if I go 12 times 3, do I get 36? And if I go 36 times 3, do I get 108? This is a consistent ratio. That means we're multiplying by the same term all the way through the series. All right, so let's try to write the equation for that. I know it only asked you for the ratio, but we're going to go further. Our ratio was 3. So our formula starts out a sub n. The first term, a sub 1, is 4 in this series. So we're going to put the 4 down. And then we're going to multiply it by the ratio. Now we just said we multiplied by 3. So our ratio is 3. And remember I told you the n minus 1 stays in the problem. So we just wrote the equation for this geometric series. Okay? All right, let's look at number 2. 5 and then to 10. We could say we multiplied by 2. But we would also say we added 5. So let's see what the next thing does. We added 5 more, right? And we added 5 more. So we did not use geometric series. This is arithmetic series. Okay, let's look at number 3. What can I multiply 120 by to get negative 60? Negative 1/2. So let's just see if we did that same thing here. If I multiplied negative 60 times negative 1/2, will I get a positive 30? Yes, that's a 2. All right, if I multiply 30 by negative 1/2, will I get negative 15? Yes. So that's my ratio. I'm multiplying by negative 1/2. So let's write the equation. A sub n. Our first term in the series is 120. We are multiplying by the ratio, and we said it was a negative 1/2. Now I am going to put it in parentheses because it's a negative number. Usually try to do that. All right, and then our n minus 1 stays in the exponent. Okay? Now, can you figure out whether you are using geometric sequence in number 4 Are you multiplying by something to get this next number? If I multiplied by -4, would I get that? If I multiply this by -4, will I get 16? All right, and so that pattern is standing true all the way through. So that's our ratio. So we would say a sub n equals the first term, which is a 1, times the ratio, which is -4, is raised to the n minus 1. Okay, so that's writing the equation for a geometric sequence. All right, so on your worksheet, you will notice you've got a couple things to do. Okay, so let's look at this one. It says find the next 3 terms in the geometric series. All right, they already tell you it's geometric, so you got to be multiplying by something in this series. So 4 times what gives you 8? And does 8 times that same number give you 16? Yes. So we're going to multiply by 2. So 16 times 2 is 32. 32 times 2 is 64. And 64 times 2 is 128. So we found the next 3 terms in our series. Okay? All right, what about number 10? What are you multiplying by? From here to here, what do you multiply by? We're multiplying by 5. Now, we got to make sure that if we said 15 times 5, will we get 75? So 5 times 5 is 25. Carry your 2. 5 times 1 is 5, and 2 is 75. So it does go through the pattern. Now, we need the next 3. So we're going to multiply that 75 times 5. And we'll get 25, carry the 2, 35, and 2 is 37. So 375. So these are going to be big numbers. So we're going to multiply that by 5. 25, carry the 2, 35, 37. 15 and 3 is 18. So 1875 is our next number. And then if we take 1875 times 5, we get 43, 9,375. Okay, so kind of big numbers, but you have a calculator that will help you. All right, so all you had to do here was write the next 3 terms in the series. All right. So let's look at 13 through 18. They want you to know, is it a geometric series? And if it is, let's write the equation. Okay? So what would I multiply 400 by to get 200? Can I multiply it by a half? And if I multiply 200 by a half, will I get 100? Okay, so we know what our ratio is. And we know what our first term is because it's the first term listed. Okay, so let's write our equation. A sub n equals the first term times the ratio, which was 1/2, raised to the n minus 1. That's your equation. Okay. What about the equation for number 14? What is your ratio? What are you multiplying by? 5. What is your first term? 1. So let's fill in the formula. 1 times 5 to the n minus 1. Now that 1 in the front is not necessary, but it helps us understand what we have in our equation. Okay? All right, so I think you can do those. Just find out what are you multiplying by, or see if it's geometric. So if I look at this one, 8 times what will give me 12? So let's say 12 divided by 8. Because remember, I'm just going to bring you back to this, and then we'll come back. Right here it says found the ratio. Found by dividing each term by its previous term, okay? So if we take 12 and divide it by the previous term, we should get our ratio. So 12 divided by 8, we can reduce by 4s, that's 3 halves. So if we're multiplying this by 3 halves, let's just make sure we're doing the same thing here. So if we have 18 over 12, we can reduce that by 6, and again it would be 3 halves. Okay, so you know your ratio is 3 halves. Your first term is listed in the series as 8. So 8 times 3 halves to the n minus 1. Okay, now sometimes it's not a whole number that you're multiplying by, but in order to find out, you take second term and divide it by the first term. That gives you your ratio. Okay? Alright, so now we have a table. You're going to have to use your calculators for these. We're going to discuss them in class a little bit deeper. But you're going to go to Stat and Edit. Remember when we went there to find the equation of a line? Well, we can find the equation of an exponential function. Okay? So it says write a rule to represent the car's depreciation. Alright? So we want the rate and we want the initial amount. So we're going to find the equation in the calculator. So go to Stat and Edit. In L1 you want to put the years, and then in L2 you want to put the value. Okay? So once you do that, you're going to go Stat, Calc, and you're going to look for EXP REG, exponential regression. Okay? Alright, so once you put that into Stat Edit, and then you did Stat Calculate exponential regression, you should have gotten an equation. So that's the rule they are looking for, the equation. Alright? So our equation says y equals, the first term was 12,500. Our ratio, or our R value, on the calculator says 0.8. Now 0.8 means 8/10, which if reduced by 2's would be 4/5. So you could put the 8/10 like it is in the calculator, that's perfectly fine. Or you can use the 4/5, that would be fine as well. And you notice in the calculator it says it's raised to the x. Okay? Now, what they want for number 20 is what will be the value of the car after 10 years. Now, where do you think I need to put the 10? The 10 should go in the exponent. Okay? X is representing years. Okay? So right here in our table, we notice the X value is the year. Okay? So we're going to put in our calculator 12,500 times 0.8, and we're going to raise it to the 10. Okay? So let's see what we get. 12,500 times 0.8 raised to the 10. Okay? After 10 years, this car is worth $1,342.18. Okay? So you're going to use your stat calc, and then you're going to use your exponential formula for geometric series. Remember, that is a sub n equals the first term times the rate to the n minus 1, and that's what we're going to be working with. Okay? So, good luck.